Hey everyone, good morning, good afternoon, or good evening from wherever you are joining us in the world right now. I'm very delighted to see so many of you joining our webinar today, which focuses on the application of PwC, where it is all about introducing advanced features for microclimate modeling and pedestrian safety. My name is Yusuf Murat. I'm the host for today's session, and I'm the product marketing engineer here at SimScale. I'm joined by my two great colleagues from SimScale, who are also experts in the field of PwC, namely Richard Sökeschula as well as Darren Lynch. Richard has a background in applied mathematics and mechanical engineering. He is our product manager at SimScale and dedicated to make SimScale a better fit for every engineer in the world. So is my colleague Darren, who is experienced in CFD and engineering design. Darren studied aerospace engineering at Brunel University and is part of the application engineering team at SimScale. Just as a side note, at the end of this webinar, we will have time to cover all your questions in a nice Q&A session. So if you have any questions about the platform of today's webinar, please put them in the little Q&A box and we will make sure to take them one by one at the end. So SimScale was founded in 2012 in Munich. Our headquarters is based in Munich and we have offices in Boston as well as in New York. We are currently more than 90 employees across 8 different time zones and with more than 250,000 simulation projects and more than 1 million simulation jobs. We are the go-to platform for engineering simulation. So what is SimScale doing in the first place? So SimScale is empowering engineers to innovate faster, efficiently, and more effectively. And SimScale is basically curing the pain that traditional CAE tools created in the first place. One example would be, for example, the high entry cost barrier, which can add up to a 4 or 5 digit number before you can even prove the added value of your hardware that you acquired. SimScale solves the biggest pain points of CAE users by enabling them, or you in this case, to simulate in the early stages of your R&D process and throughout the entire R&D process, also across your entire organization. And what SimScale delivers is computational resources that scale up on demand, offer modern sharing and collaboration tools to enable you collaborating with external partners or internally in your organization, and we enable streamlined simulation workflows. Let us have a look at today's agenda or today's application. So we'll have a look at the advanced features for microclimate modeling, and this is subdivided into 3 parts. So that's, first of all, seasonal wind data, then we move on to Gust Equivalent Mean, and we will talk about outdoor thermal comfort, where we talk about co-simulation with Grasshopper for advanced microclimate analysis, followed by a nice demo by my colleague Richard. And with that, I now hand over to you, Richard.
Yeah, thanks, Yusuf, for the introduction and for hosting the webinar today. Yeah, as you already said, today we would like to present to you some of the new features that we have recently been releasing on SimScale that are especially targeted for advanced use of the pedestrian wind comfort analysis on SimScale. And then also on top of that, how this can be used in consecutive workflows where we enhance the results we get from SimScale with additional data like solar radiation and others to derive more more advanced comfort criteria like thermal comfort and others. So let's start with the first feature for today. So something that has been requested since the beginning, basically, when we had the first pedestrian wind comfort analysis on SimScale, was the ability to also evaluate the wind comfort on a seasonal data level. Before the latest release, you would only have the ability to upload one specific set of wind statistics for a pedestrian wind comfort study. You would run the CFD analysis first to get the local wind conditions, and then we would do, based on that, the statistical evaluation of the results to get the comfort criteria. So basically, how often in a year the wind would exceed a certain threshold velocity. And if you would need to evaluate that on a seasonal basis, you would basically need to make a new study with a different data set and run the complete analysis again. Obviously, there's a waste of resources doing that. Now finally we are able to provide this feature to our customers. So whenever you have finished a normal pedestrian wind comfort study, you will see at the at the run panel a new small button next to the post-process results, where you can click on it, and then basically the only thing you have to do is you upload the new wind statistics that you wanna apply, and click start. And what it will do is it creates a new run, which is a copy of the old one from the CFD results point of view, and only does the statistical evaluation of the results based on the new wind statistics that you got. And this will be a lot faster and a lot cheaper than just running the full analysis again, obviously. So we are able to cut down the cost and the runtime of these seasonal data evaluations, which is really a great benefit for our customers. This will be working also for old data sets that you have generated before. So any result that is finished is now able to be continued with different wind data on SimScale. I will also show later on the live demo how this works and how you can upload new data and what you will get as a result. There will be a fixed cost to this, so each new data evaluation will come at a cost of 1 GPU hour. So the GPU hour is basically the measure of effort of a computation throughout all the pedestrian comfort based analysis on SimScale. So in this case, we have a fixed cost. There's no variable cost. It's not related to the initial run cost. It's just 1 GPU hour fixed. Then another feature which we have been requested to add since quite some time was the ability to not only evaluate wind comfort based on the mean wind velocity, but also taking into account turbulence effects, so the gust wind speed as well. The baseline here is that the wind comfort and also safety is not only related to the mean wind speed, but also wind gusts can have an adverse effect on the sensed comfort of a person in an urban environment. So you can imagine you drive with a bike across a street crossing, and there's a sudden wind gust coming from the side. There's a high risk correlated to that, whereas the gust itself would probably not be seen if you would only compute the safety criteria based on the mean wind speed, because it could be just averaged out over the transient runtime, as it is a relatively rare event, and it's just a fluctuation around the mean wind speed. So what we did is, as you might know, the pedestrian comfort analysis in SimScale is run on a detached eddy analysis, so it's fully transient, and this is a mix between a URANS simulation and an LES simulation. So we have parts of the turbulence in the air that is resolved, so that is fully resolved within the velocity fluctuations of the wind, and there's still a part that is modeled within the equations of the system. And what we did is, for computing the Gust Equivalent Mean, we basically take both parts into account. And as a user, you don't have to basically check based on the mesh fineness, for example, if you're in a fully resolved region yet or not. It's automatically taking into account both parts that make up for the gust from the standard deviation of the velocity. So when running the transient analysis on SimScale, we compute on the fly the standard deviation of the velocity at each point of the pedestrian level. And as well, we get the modeled turbulent kinetic energy at the same points. And in the end, we combine this together to the total velocity standard deviation. And this is then added together with the mean wind speed to the gust speed, right? So the gust speed is basically telling us the highest wind speed that we can expect for a 3-second period. And then what is done to be able to compare the effects that a wind gust has on a pedestrian compared to the mean wind speed, there is a gust factor applied, which is in this case 1.85. So this 1.85 division makes both results comparable. So we can apply the same criteria for comfort and safety based on the gust wind speed evaluation. Then we can use for the mean wind speed. And obviously, what you can also do, or what is also automatically computed, is not only the wind comfort based on the mean wind speed and on the gust equivalent mean, but also on the worst of both, because that is in the end the condition that is relevant for the safety criteria and the comfort criteria. So both, all three results actually can be evaluated within the post-processing environment. And we can see later how this works and how the results look like. Yeah, obviously an important factor whenever we deal with safety criteria and whenever we introduce a new feature is making sure that the results are valid and we are not creating random results. So just quickly introduction to a validation benchmark that we have been running. So the Architecture Institute of Japan has a vast set of benchmark cases that they have published, and they're publicly available, as well as the results from the wind tunnel studies. In this particular case, we chose AIJ case D because in the wind tunnel, they also measured not only the mean velocity, but also the turbulent kinetic energy. So we could compare with the turbulent kinetic energy evaluation that we're doing now. So it's an idealized geometry. It's not really a natural urban environment, but still the results are comparable. In this case, we only ran one wind direction. Here there are two others that I don't present today. Just for some metrics, right? To show you that these results are not really manufactured in a way that we optimize for the highest accuracy, but have in the end a cost or a turnaround time that is not realistic in everyday's application. So in this case, as always, setup time is super fast with the pedestrian wind comfort analysis on SimScale, about 10 minutes. But more importantly, the computing time is under 2 hours for this case here. So the cost would be also 1.9 GPU hours. And then on the results, we also compared the mean velocity, which even has a better correlation than what we see here for the turbulent kinetic energy. But let's focus today on the turbulent kinetic energy. So on the bottom, you see the comparison of SimScale results in blue to the wind tunnel results in black. So what we can see is that we follow nicely the trends of the turbulent kinetic energy. We also are in line with capturing the peak points where the highest turbulent kinetic energy is happening, which validates that the methodology that we are applying, basically combining the modeled and the resolved part of the turbulence, is valid. And with that, we can go over to the live demo. I encourage you to ask questions directly in the questions option here on GoToWebinar. We will, as said, have a look at the questions later. So as you can see here, I just have a sample demo of a city, which I have run an annual wind comfort study on. So you can quickly have a look at the results of the scenario here. We now have a look at the Lawson LDDC comfort criterion And so here we see the SimScale post processor, and we can see the different wind comfort criteria. We can evaluate the NEN 8100 based wind comfort, for example, the Lawson 2001 one, and others as well. But most importantly, what we want to have a look at now is the different types of comfort we now have available. So we have the mean velocity, as said, but then on top we have the gust equivalent mean. So this is basically the evaluation of wind comfort based on the gust equivalent mean speed, as you can see here. And then what you can also have a look is the maximum of the gust and the mean speed. So this is in the end the most complete view that you can have on the wind comfort results on SimScale. For the individual directions, what we also have, if you go to, so you have here the different directions that have been run. So 0 degrees, 45 degrees, always from north. In the average result, which is the average across the transient period, we have here in the solution fields as always the mean wind velocity, you can see here. But additionally, now with the new feature, we have also the velocity standard deviation directly output. So you can see, for example, here in the wake region of this large building here, we can see an area with a high velocity standard deviation. So we can assume that we have high fluctuations of the wind speed here in this area. And additionally to that, we still have the modeled turbulent kinetic energy. And as you can see, maybe we can scale this a little bit down. Yeah, that most of the turbulence that we have in this analysis are actually resolved. So we have here higher values for the standard deviation of the velocity. Now coming to the seasonal wind data. So you can see here that this was a fairly large analysis with 28 million cells. It took about 4.5 hours to compute and cost 17 GPU hours. So now, obviously, I don't want to run the study again if I want to just have a look at the wind conditions in winter, for example. So we have this new wind data here. We are prompted to upload the new wind data, which, for example, let's do for the sample spring data. And the wind data that we upload here might have more than the wind direction that we actually are evaluating in this study here. So we used here 8 wind directions, but we can use any data that has more than 8 wind directions as an upload. So for example, we can use a wind data that we've got for 36 or 16 wind directions, which will automatically get reduced to the 8 wind directions here. So we see the cost as 1 GPU hour, we start, and then the evaluation will be started. So we have here a new run and see that directly we have the same results as we had before, and the post-processing is happening. While that happens, I want to quickly jump back to the statistical results to show you a couple additional features that maybe are worth mentioning before time runs out. So let's have a look again at the wind comfort here. So what's often happening is if we are interested in seasonal data, we obviously want to compare also the different seasons, right? And the output of a wind study, what is in the end added to the report, is usually a picture, a screenshot of the results. And what's important there is that these screenshots are comparable, right? So we added a nice feature here on the bottom right. I hope you can see it, but next to the orientation cube, there is a small camera. And if you click on it, you can save a view. So I have this view here, and I can rename it side view. And the nice thing is I can refer to this view again on any result that I have in this project here. So I saved a top view previously, so I can get back to the top view and be sure I'm taking now exactly the same screenshot as I have defined before, maybe in the annual result, which makes the workflow a lot easier. Another feature that we just have released is you can resize now the screenshot. So not only you can change the aspect ratio, but also have a higher resolution of the images that you take. So I'm taking out a screenshot here, and then if I download it, I will seeing that the screenshot has a much better resolution than the default size of the screenshot that we have. So with this, I can conclude the demo part. So we have seen how to add new wind data for seasonal data evaluation. We know how we can choose between the different types of comfort based on the mean, Gust equivalent mean, and the maximum of both. And some handy features how to ensure we always get consistent views for screenshots and how we can resize them. And with that, I hand over to Darren.
Thank you very much, Richard. Great demo, thank you. I'm here just to give a update, I think, on the external thermal comfort side of things. So this is a naturally evolving project that we've got going on that's really a workflow to generate these UTCI values using SimScale results. Let me just give you a refresh for those who haven't seen our webinars in the past or our content in the past about what this is actually about. So UTCI is the Universal Thermal Comfort Index. So it's kind of like a perceived temperature. So if I was walking through a city, how warm or how cold would I be feeling based upon the wind speed, the mean radiant temperature based upon the exposure to the sun, the ambient temperature, and also the humidity of the area. So these are the kind of things that we want to find out using an analysis like this. And what we did is we devised this workflow that essentially takes pedestrian wind comfort results that's similar to what Richard just showed us, take those results and bring them into Grasshopper, evaluate the Universal Thermal Comfort Index using the Ladybug tools, and generate our outputs. So the workflow thus so far really is to firstly run the PwC simulation in SimScale. We can then download those results. Now, recently we also sped up this process a little bit by involving the SimScale API. We pull these results via the API to our local environment, and then what we do is we format them so that we can actually read them into the Grasshopper environment. So that's the recently automated part. And then of course we read it into the Grasshopper environment via CSV scripting, and we've got a few examples here as well. Now, going forwards, we're also continuously developing this workflow. So what we're also doing now is thinking about how we can automate this and how we can make it a bit more streamlined, maybe bringing it into the cloud environment. So what we are really asking is if anybody is interested in this workflow, who would like to be involved in maybe some early stage testing, then please contact us, either myself or Richard Skidler. We've got our email addresses on the question and answer section, so it would be really great to hear from you, and maybe have a discussion about what you wish to do with this workflow and how we could help you make it work. Good. That's all from my side. And once again, if you've got any questions, please type them in the questions section. We've got that coming up in just a few minutes. Thank you very much.
Thank you so much, Richard, and thanks, Darren. Thanks, Richard, for the nice presentation, also showing many great features that we have on our platform. So for the Q&A session, as Darren already mentioned, please put them in the Q&A box, and we'll cover now a few of those. The first question being, do I have to keep my browser open when a simulation is running?
Yeah, no, you don't need to. So the process is started whenever you click the Start Simulation button. From that point of view, it's completely decoupled from your browser. You can close it. Whenever the simulation is finished, you will get an email notification, and you click on the link that is provided with that, and you're directly forwarded to the specific simulation result and are directly in the right environment to evaluate your simulation results.
Great. I think that covers it, Richard. Thanks. Next one would be, can I run multiple simulations at the same time? When I use desktop software in the past, additional simulations would queue. Richard, again, if you want.
Yeah, this questions come up very often. So yeah, that's one of the key benefits from the cloud being detached from your local machine. We can run many simulations at the same time. It doesn't really matter how many you want to start. You can just evaluate multiple variants at the same time.
Excellent. Can I export my PwC runs and post-process them with another third-party tool like ParaView? Whoever wants to take it.
Yeah, I can take that. Sorry, Richard.
Go ahead.
Yeah, absolutely. You can download all of these results and post-process them locally. And in fact, in theory, that's what we do for the external thermal comfort workflow anyway. So downloading each individual wind direction result as well as all the statistical results is absolutely possible from the SimScale platform.
Great. Additional questions. I think a very interesting one is, which CAD formats are supported? Can I upload Revit files?
Okay. Yeah, so we provide a wide variety of CAD file formats that you can upload. You can use Revit, Rhino as well, step files, neutral file formats, STLs. There's a variety of CATIA even. So all the major file formats are available. SolidWorks, yeah.
I think that covers it.
I think the only important thing is that we work with 3D data, right? So if you have a 2D CAD file format, that would not be very useful in SimScale. So it must be a 3D file format.
Thanks for clarifying. I think we have a new one coming in, which is also very tricky. Where can I get the seasonal wind data from?
Yeah, that's indeed not as easy. There are a couple of websites or national weather agencies that provide seasonal weather data or even historical weather data by the hour for the last 30 years. That would be one source. If you have a trusted provider, or if you don't have one, you can ask us. We can forward you some of our contacts. But yeah, there are some freely available tools on the market or data that usually national weather agencies provide that you can download and then just use with SimScale.
Excellent. Thanks, Richard. Another question is, you spoke a little about automation. Can I run SimScale programmatically from Python or MATLAB?
So yes, automation completely possible via the API. Currently, Python is a supported API platform, as well as C#. So no MATLAB currently, but API via Python, absolutely. And yeah, from the API, you can essentially control everything in the SimScale platform programmatically.
Awesome. Can I measure the signal of the air velocity at a particular position and export to Excel, similar as in wind tunnel tests?
Yes, absolutely. Natively supporting the SimScale platform. Yeah. We also do an analysis on those signals for you, giving you the average, the maximum, the minimum, and the standard deviation as well.
Great. I think we have a last one coming in, which is, can I use a common EPW weather data for seasonal analysis? I think that one is for you, Richard.
Yeah, we do not directly support EPW, but there are ways to convert EPW to stat files. So, for example, with Energy Plus, you can convert EPW to a stat file. But the stat file format itself is also very simple, right? It's more or less a table of velocities or velocity buckets versus wind directions, right? This is very easy to even get from Excel once you have the original data. But yeah, tools like Energy Plus help. There's also other websites available like this Ladybug EPW map, where you can not only download EPW but also stat files that come at the same time in the zip file that you get from there.
Great. We have some questions coming in about pricing and also about the on-demand version of this webinar. So pricing is something that has to be discussed, I think can be discussed via email. So the contact details from Darren or Richard are on the slide. And regarding the on-demand webinar, this will be made available at least 24 hours. Let's see if we have another question. Can we import data from ArchiCAD or IFC format?
Yeah, currently not. So IFC is something we want to support in the future, but currently it's not yet directly available. We're working together with a third party that with them we could make it available, but currently this is not yet there. I also see a question maybe related to a previous topic regarding different periods. Instead of seasonal data having a specific time of the day between 9 to 5 or just a few months of the year. Yes, of course you can also do that. The only thing is you have to prepare your data in a way that it's consistent. So basically, whatever you upload on SimScale might be a seasonal data set or a yearly data set or just a slice of the day for the full year. But it should add up together to 100% coverage of whatever time frame you're looking at. So if that is the case, then the criteria apply again, and you can evaluate it as usual with the workflow that we have shown.
Also, just to add on to that, Richard, I've actually done this in the past as well. So if you wanted help with that, I can show you how to automate that workflow.
Maybe one question that I also take up. The question was, it's hard to understand how we go from the first 3 images to the 4th image on the slide that we had on the Gust Equivalent Mean here. Yeah, so the problem is that the first 3 slides show the wind results for one particular wind direction. I think it's north in this case, so from the top, right? And the picture on the right side presents the overall yearly or seasonal wind comfort criterion. So there we basically take all the directions that we have computed and combine them with the weather statistics. So there you don't see usually much directionality with the results, but more, a combination of the prevailing wind directions and also obviously on the local architecture and the massings of the building.
Great. I think we have one question, which is also very common. How many wind directions can I run simultaneously?
So if you want to run a pedestrian wind comfort study, you can run up to 36 wind directions. We also have a single directional analysis, which is called incompressible LBM, which is the same technology, but you have more freedom, but you don't have the statistical analysis, and there you can run many more at the same time. That's up to you. There's basically not really a limit on the number of directions, but 36 is what we can do with the pedestrian wind comfort study, and as far as I know, there's not really a need to run more than that.
I'd also like to just answer, is this type of analysis always 2D, or can the results vary in the Z direction? I think it's quite important to note that all of these simulations are transient analysis in 3 dimensions. So although we're looking at the results on a 2D slice or an offset surface from the ground, all of the results are generated in 3 dimensions. And also we've got a question, what type of file is required for the building geometries? Can I use Rhino files, etc.? Maybe just to hit that on the head. The most common file format for pedestrian wind comfort tends to be from Rhino or Revit, in which case we prefer to export these as STLs and upload them to the platform.
Great. Thank you so much, Darren and Richard, for the nice presentation, also covering a lot of questions today. If you have any additional questions, ladies and gentlemen, feel free to contact my colleagues. The contact details are on the slide. And with that, we conclude the webinar. Thank you so much, Darren and Richard again, and see you in the next session.
Thanks very much, guys.
Thanks everyone for joining.